Alright, welcome back. We're going to look at the 2x8 to the max. This is 2.0. We're going to go into a lot more detail because I ended up getting a lot of criticism and comments. A lot of questions, really, and they were all founded from different places. So I thought, you know what, let's just go ahead. I'll rip that other video down. We'll reshoot another one. And hopefully it can answer a lot of people's questions. Okay, so we're going to go right into running with watts. About 14 volts-ish. The Kyoto dropped about 14. We're starting out with a 1,000 watt slug. We're in 1X. We're going to look at it in PEP, 5 watts in reverse. And another question I had was, I look at everything on my Siltronics meter. I use a 5 watt position. I read it in reverse, coming from my Galaxy DX66V. This is my input tune. Hello audio. Hello audio. So less than a watt in reflect going into the box, or coming out of the box from input tune. As you can see, we're around 14 volts again. Hello audio. Okay, so we just slammed it in a corner. We're going to go to 2X again. Hello audio. So we're back out there around the 18 mark. We're going to take it down to 5X for a reason. I'm going to demonstrate to you what this thing does in 5X position. So otherwise that slug is now the equivalent of a 5,000 watt slug. Hello audio. Okay, so we've all seen it do about 16, 17 on the 5X. 1,000 watt slug out the way. 5,000 watt slug put in its place. Back to 1X. So now the 5,000 watt slug is reading 5,000 watts. Hello. Now what that shows us is that the scale is linear. There's no trickery. That being said, we're going to go over here and look at the spectrum analyzer real quick. Hello. Hello. Alright. Shut this off for a second. Pop the top off. Grab a ground up. On the output side, I'm going to hook a 10-to-1 induction probe to scope. Hello. Turn the amp back on. Hello audio. Hello audio. Hello audio. Hello. Brett, I hope that answers your question. I don't know what else I can do to help answer your questions there, buddy. Alright. Another thing I've had a couple questions about is, let's talk about resistors. 2 watt standard Fat Boy Dave made X-Force. I use 5 watt. I cannot point out to you enough, I built this as a product demonstrator, and I built it for me. I had all these thoughts running around in my head, all these different things I had envisioned, and I said, what would happen if I built the box for myself with this technology in it? What would be the improvement on the wattage? What would be the signal? What would change? So, the only way to answer those things is to build yourself a product demonstrator like this. So, that opens up the door for me to be able to do anything I want, anywhere in the circuit. And one of the things I chose to do, instead of using this incredibly cheap part everywhere in the box, I used the slightly little bit more expensive, higher quality part everywhere. The upside to having 5 watts everywhere in your box, especially in key points. Output, 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 input. And over here on the input side is it builds lead time into the box. Now, this isn't gobbledygook. This is the truth. If you're volting the crap out of your box, or you have a pill that goes out and causes the circuit to go to ground, otherwise it becomes unstable and starts to oscillate, which do you think is going to suck up more current and last longer? The one on the right or the one on the left? Obviously this one. It builds lead time into the box, and what I mean by lead time is everything going on in here is happening at the speed of light. It gives the human brain a chance to catch up and to realize there's a problem inside the amp. So the only thing you end up burning up is the 5-watt resistor. The way most boxes are put together today, it uses 2 pills plus 2 pills, and they combine together. They're split apart on the input and then combined back together. If this half of the circuit becomes unstable because one of the pills has gone bad, the only thing that's saving these 2 transistors here is that resistor. It allows you to see the watts drop off on the meter and go, shit, I better get off the key and unkey. I don't know about all you all. I'd rather replace a whole bunch of these than replace a whole bunch of these. Because if you catch it in time, you'll end up replacing the 1 pill instead of all the pills. Because once this entire circuit fails, this entire circuit fails. That's the upside to using a slightly bigger resistor. Are they cost effective? No. Are they great for mass production? No. That's what I wanted to do, so I did it inside my own amp. The other thing I always had a dream about is this is your standard choke, RF blocking choke for your power supply circuit. These little wires are what carry all the current for 2 transistors. You can't tell me that this isn't a little bit of a resistor. I went ahead and used this. It's the exact same theoretical purposes as this, but on a much massive scale. They're right here. So you got your copper board for your strip for your power supply. They go through the choke, then they go down to another copper board. If you can see, copper board, copper board, copper board. Instead of soldering it all the way on the back of the output transformer and letting this little bit of surface area carry all the current load, which can be up around 65 amps, to the entire circuit, I went ahead and spread it out all the way along the length of a 1-inch strip of copper board. More surface area, bigger parts, better cooling. The more current you can provide to the transistor will translate to more watts, and the part will run cooler. Period. Hence the more ground. It also took a lot of the harmonics out when I applied this ground board, because this transformer can't see this transformer. Allowed the circuit to quiet down quite a bit. One last thing. This resistor has to suck up, this one right here, has to suck up 100% of the energy when you come off the key, because everything is still working in here. Even though the input watts have stopped and you've broken your connection with the antenna, for 1/1,000,000 of 1 second there's still 100% of the RF being generated until the transistor shut off. The only place for that current to goes into this little resistor. Or not have the resistor there at all and let all the wattage reflect directly back into the transistors. And you know, Bat Boy built that way for a lot of years. This versus this. The debate is on. The watts don't lie. Spectrum scope don't lie.
BBI.
I said, boys and girls, it's out there. Once again, this was a product demonstrator I built just for myself. I thought I would share it with you all. Bump, bump.